In this video, we're looking at more problems involving products of powers. Let's get straight into the first one. We need to fill in the missing indices. What we've got here is m to the power of 4 n to the power of 5 multiplied by m cubed n to the power of 8. Now, remember, there are invisible multiplication signs in here and here. So what we really have is m to the power of 4 multiplied by n to the power of 5 multiplied by m cubed multiplied by n to the power of 8. Now, it doesn't matter what order I multiply in. So if I multiply m to the power of 4 by m cubed, I'm going to get m to the power of 7. You can see here we've got the same bases, so we can just add those indices. And then we can multiply by n to the power of 5 by n to the power of 8. And those two have the same base, so I can add those indices to get n to the power of 13. And because we're working in algebra, we can leave out this multiplication sign between these expressions. So I simply get m to the power of 7, n to the power of 13. Those are my missing indices here. Once you're comfortable with the idea, you don't need to show all of this working. You can see for yourself that we can simply add the indices. 4 plus 3 gives us 7, 5 plus 8 gives us 13. Pause the video and have a go at the rest of the questions. Here are the answers. In question B, we've got m to the power of 4 multiplied by m to the power of 3 multiplied by n to the power of 8. Don't forget the invisible multiplication sign there. Now, m to the power of 4 multiplied by m to the power of 3 is m to the power of 7. And then if we multiply that by n to the power of 8, we end up with m to the power of 7, n to the power of 8. Notice we're just looking for when we're multiplying powers with the same base, and when we are, we simply add the indices. So because these have the same base, I can add the 4 and the 3 to get the 7, and then I'm multiplying by n to the power of 8, so I need to multiply by n to the power of 8. There is an invisible multiplication right here. Now, with part C, we can do the same kind of thing. M to the power of 4 multiplied by P multiplied by m to the power of negative 3 multiplied by n to the power of 8. Well, let's consider the m's first of all. I've got m to the power of 4 multiplied by m to the power of negative 3. If I add 4 and negative 3, I get 1. Looking at the n's, we're multiplying by an n to the power of 8. So it's just n to the power of 8 in here. And then looking at the p's, we're just multiplying by a p here. And there is an invisible 1 right here. So we've got p to the power of 1. So for the purpose of this question, we have answered it. We've filled in the missing indices. But normally, we don't bother writing in indices when they are 1. M to the power of 1 is just the same thing as m. P to the power of 1 is just the same thing as p. So it would be simpler to write this as m, n to the power of 8, p. Let's move on to question D. We've got a to the negative 2 multiplied by b multiplied by a to the power of 2 multiplied by b to the power of 3/4. Focusing on the a's, we have an a to the power of negative 2 multiplied by a to the power of 2. So we can add those indices, negative 2 and 2 add up to 0. So that gives us a to the power of 0. Then multiplying by the b's, we've got b to the power of 1 multiplied by b to the power of 3/4. And when we add 1 and 3/4, we get 7/4. Remember, 1 whole is 4/4. So 4/4 add 3/4 is 7/4. And there's our answer. We have filled in the missing indices. Now, just like in part C, the answer we've got here is something we wouldn't normally write out. We know a to the power of 0 is just 1. So what we've got here is really one lot of b to the power of 7 over 4. And simply, that is b to the power of 7 over 4.